Good morning. So today, let's estimate U-type lined canal. So I have prepared this presentation. Let me screenshot this first. Okay. Now this is the U-type lined canal we are talking about. This is now the structure we are going to estimate. As you can see, it is really U-type in a U shape, right? So here it is already presented or reflected the dimensions we are going to use in our estimate. And also we have here the specs as our reference. And then in the right side, we have here the Excel file for our estimate process. Okay, so where should we start in this Excel file? Let me maximize this. So here is the tabulation or the data we are going to fill in for our estimate. I have highlighted the boxes we are going to fill in for this estimate. As you can see, this box here is for our RSB quantities per linear meter. We're going to estimate only for 1 meter. Okay? I-consider lang natin yung 1 meter na line canal. So let's start with filling in these boxes here. For bar type, so what is bar type? So bar type is yung designation ng bars na ibibigay mo to identify its type. Okay? So makikita mo yan doon sa bar diagram. Okay? Bar bending diagram. I'll show you. Oh, wala di. It is here. Bar bending diagram. So, ito yung itsura ng bar bending diagram. Dito mo itignan yung kung paano ibibend yung bars. Okay? Ito rin yung magiging guide ni Stillman. Okay? So, si bar type, ito yun. Letter A. Capital letter A and capital letter B. A and B lang yung bar type natin. Kasi, let's go back here. Makikita natin, yung bars na gagamitin lang dito for our U-type canal is just 2 types. Okay, this in color red, which is the straight bar. Okay, this red one. And then, the second type is this in blue, in color blue. I colored it already. Okay, so this is bar type 1A and bar type B. Okay, so let's go back to the bar bending diagram. Now, here in our bar bending diagram, we also have small letters. So these small letters, we are going to find out how long or the dimension of this. We are going to fill it, and it will only be based on which type of bar. Okay, so we're going to fill in this column, the bar type. As I've said a while ago, it is A and B. So for our straight bar, the A, and for the second, the cross-sectional is B. This our bar type A is the longitudinal, and the transverse bar is this bar type B. Okay, let's now start with the bar type A. So in this column, we are going to find out the spacing for bar type A. Let's go back here, and now let's check the specs. As you can see, we have here the bar type A. The bar type A indicates 7-10 mm this sign is called diameter. Okay, so 7 does 10 mm diameter. So where's the spacing here? It is not reflected here, right? So what are we going to fill in this box? Dahil wala yung spacing dito nakalagay, but anong ibig sabihin ng 7 dito? This 7 indicates that 7 pieces of 10 mm. Okay? So, hindi na siya kailangan ng spacing dahil nilagay na niya kung ilan ang kailangan. So, let's count here. So, the longitudinal bars or our bar type A is this in red colors. So, 1, 2, 3, 4, 5, 6, and 7. So, this data here is correct. So now, because we are asked for the spacing, we just input here as shown. Okay, as shown. Then, let's proceed in this column, the bar size in millimeter. So, what is the bar size for our bar type A? It is 10 mm. So, just type 10. And then we are now required to fill in these boxes, the bar bending section. So for our small letter A in meters, okay, let's go back to the bar bending diagram and please just familiarize these figures. For our bar type A, it's just A. So we are required how long this A. Since this is our longitudinal bar and we are quantifying, we are estimating just 1 meter of the U-type canal, then this A should be 1 meter. So we're done here, and then we have the bar length. This bar length, and by the way, we don't have anything to fill in here in these boxes because ito lang yung itsura ng bar type A natin. It is only the longitudinal straight bar, right? So these boxes are not applicable. Just leave it alone. Just leave it there. Just leave it blank. So this bar type, bar length in meters, is just the sum of all these boxes. Okay, so 1 meter. Now in this column, we are required for the quantity. So how many is our bar type A? We have already counted it a while ago, and it is reflected here, indicated here, 7 pieces. Alright, so just input here 7. And this total length in meter is just the product of this quantity times this bar length 1. So that is 7. By the way, in this unit weight, which is the kilogram per meter ng RSB natin, makikita natin na naka-program na yun. So, let me show you how it works. Okay. Dito sa bar type natin, it's 10 mm. This will change if you change this bar size. For example, we have 12 mm. So the unit weight here will change because it is already programmed. Also, you can check this on Google. Just type unit weight of RSB and what size of RSB you are curious about. Okay, example 16 mm, or like that. So input here. So that's it for our unit weight. Now for our RSB weight per meter in kilograms per meter. As you can see in this column, it is the product of unit weight times total length. But if you asked why kilograms per meter pa rin, when you multiply this, it should be meter times kilogram per meter. So meter should be cancelled, right? This should be in kilograms. I just put it here kilogram per meter because we are quantifying per meter. Okay, so just put kilograms per meter kasi we are estimating 1 meter. So this is, multiply this, just check it yourself. Multiply unit weight times total length, and this should be the answer. Now let's go back to our bar type B. For our bar type B, the spacing. Now this is our bar type B, the blue one. It is reflected here 10 mm at 200 mm. So the spacing is at 200. Okay. So this bar, this colored blue, should be spaced at 200 mm because we are required for the spacing for our bar type B. So let's input here the 200. And then for our bar size, excuse me, hindi natin nabalik to. Sa example kanina, this is 10 mm. So for our bar type B, it's also 10 mm. Now let's fill in these boxes for our bar bending section. So let's go back in our bar bending diagram. So please familiarize these letters, small letters A, B, C, D, and E. We are going to identify to know the corresponding length of these. Please familiarize A, B, C, D, E. So let's go back here and there. For our small letter A in meter, we're going to input here in meter, okay? So, ano yung length niya? Here, it is 63. Okay, for example, in this plan, this is not reflected. So, how will you know the length of this hook? So, let us visit general notes. So, dun sa plano, you are going to find the general notes. You have to read it from there, the specification. Under general notes, under reinforcing steel, we are going to know this. So for our hook, because it is bent like this, so it should be 4D or 63 mm. Compute muna natin if how long is 4D. 4D is 4 times the diameter of our bar type. So that is 10 mm. So 4 times 10 is 40. Pero nilagay dito or 63. Ibig sabihin dito, it is the range. Range to ng sukat dito. So since this is 40 and this is 63, that means this 63 is the minimum. So if your answer for 4D is less than 63, you are going to use 63 mm. But if it is more than this 63 mm, use that answer, okay? So use 63. 63 mm is 63 divided 1000 to make it in meter. So let's go back here. Now for our letter, small letter B. A, B, right? So how long this letter, small letter B, will be? So we have to know the height of our structure. This from here, from the top to the bottom of our structure, this is 650 mm. And we are not going to input this here that it is 65. Why? Because we still have concrete cover. Okay, for those that are not familiar with concrete cover, so this is concrete cover is this portion. Yung nag-cover ng RSB natin, that thickness is the concrete cover. Okay? So dito nilagay ko na, it is from the top of our structure to here in our RSB, it's 75 mm. And from here to here, it's 75 mm. Why 75 mm? How about this is not given? Now, again, let's visit the general note. And here, minimum clear cover, okay, in mm and inches. So, mamili ka lang dito if where it belongs. So, let's read. Concrete in a marine environment or concrete cast against and permanently exposed to earth. So, dito belong yung structure natin. Why? Because it is the concrete cast permanently exposed to earth. Meaning, yung structure natin is laging naka-exposed or laging naka-connect or related or naka-attach or it is really built on earth, right? Because it is lined canal. So it is built on earth. On earth. Yeah, we're on earth. Soil. The correct term should be for to be more understood. It should be soil. So it is permanently exposed to soil, right? So we are going to use 75 mm or in inches, it's 3 inches, okay? So for the other structure, you can check this here. Now for our example, it's 75 mm. Let's go back to this typical detail. So that's 75 mm. For our letter B, small letter B, this height or length something, we are going to input equals 650 or 0.65 meter minus the concrete cover here and the concrete cover here. So 0.075 because 75 mm is 0.075 meter. So minus dalawang 75 mm, that is 0.5 meter. So for small letter C, this is our letter C, if you remember this, okay? So for our small letter C, the width of this RSB. So now we are just going to equals this 800 mm or 0.8 minus the concrete cover here and here, here and here. So dalawang 75 mm and that's it. Then since our bar bending says that B is just the same as D, we can just equate D equals B, right? Same lang sila ng height, as well as this A and E, right? So let's equate this, and that's it. So the total of these guys is 1.776. And now we are going to find out the quantity. Now for the quantity, we are just going to, okay, input equals. Since 1 meter lang yung i-estimate natin na structure, di-divide natin to ng spacing. Okay? Spacing. Our spacing is 200 mm. Since 1 meter is in meter, and this is mm, so we are going to divide this 200 mm with 1000 to make it meter. So meter over meter cancel out. So I'll just separate it by putting parentheses 200 divide 1000, then close parenthesis, the answer is 5 pieces. But since this 5 pieces is just the number of spacing, okay, let me show you here. Let's illustrate it here. We can just illustrate it here. In meters, I'll draw 1 meter. So this is 1 meter. And for example, we are going to put our RSB here. This is our RSB, right? So for our bar type B, because it is spaced at 200 mm, let me space this at 0.2 in meters. So this is the spacing, the 200 mm. Now let's distribute it on the whole stretch of 1 meter like this. So now let's count the number of RSB. 1, 2, 3, 4, 5, 6. When you are required for the number of RSB using the spacing, you are going to add 1 because the answer, if you use the spacing, will be the number of spacing. So should be plus 1 because the 5 that we get as the answer is the spacing 1, 2, 3, 4, 5, right? But we are required for the number of RSB, so we are going to add 1. So this is now the answer, 6. Okay, and for the total length, okay, only the product of quantity times the bar length. So 6 times 1.776, 10.66, because we are just using 2 decimal. So this is the total length. And since we are required for the kilograms, then our unit weight is just the same here because it is also 10 mm. So the RSB weight per meter is just the product of this unit weight times total length. And this should be the answer. So total of these two, 4.31 plus 6.56 is 10.87. So this is now the quantity for our RSB per meter. Okay? Kaya nilagay ko yung ganito. So we're done with our RSB. Now because our structure, paano mo i-construct yung structure mo? Hindi naman yung RSB lang yung kailangan mo para ma-construct ang U-type canal na to. Right? Kailangan mo rin ng concrete. Kailangan mo din na how about in the actual site condition? This top of our structure is also the top of our natural grade line. So, kung ito yung lupa to na kung saan natin i-build yung structure natin, this should be excavated, right? In this portion, we are going to excavate this part. Actually, this portion should be excavated. Okay? Bakit may space dito? Hindi yung kasya lang. Okay? Why? Let's use this illustration here for our excavation. Now, our excavation here, the structure excavation, by the way, the item of works to be done para magawa tong structure na to is these items: the structure excavation, the foundation fill, this portion, and structural concrete, of course, and lean concrete, this here, and of course the RSB para magawa ang structure na to. Alright, okay, so let's proceed again. for the structure excavation. So this is now the computation of our area. So this should be the area for to be excavated. Now, dahil dito yung NGL, top ng ground natin, and ilalagay natin yung structure natin dito. So, ang gagawin natin is, huhukayin natin ang portion na to. Maglalagay tayo, mag-offset tayo dito kung what is applicable really on site. So, just use this portion is called the working area. So, you can change this width here into the what is applicable on site. Okay, what is really applicable on actual work. Okay, so for this example, we are using 0.5 meter. So now we are going to calculate this area to be excavated. So here the computation is 0.5. Here the working width, and then 0.8 the width of our structure, and then the working area again 0.5. So plus mo yung width or the total width, then multiply the height. The height is the height of our structure, which is the 0.65 meter, and then our lean concrete and our foundation fill is a total of 0.15 meter. 0.65 plus 0.15 is 0.8 meter. So now calculate this 0.5 plus 0.8 plus 0.5, then multiply with 0.8. The answer should be 1.44. So here, it's area. Okay, we're done with the excavation. Now let's proceed with our foundation fill. Foundation fill is here in this width times thickness. So this 0.1, so the 100 mm plus 800 mm plus 100 mm, total of 1 meter. This portion here, this portion here, times the thickness, the 100 mm. So multiply this 1 meter times 0.1 is just 0.1 square meter. Then for our structural concrete, the structural concrete for this structure, we are using class B. So how we are going to calculate the area? This is it. I've prepared it here. So this is area is just multiply mo lang yung 0.8, the width, outside width of our structure, the 0.8, multiply mo yung outside height or depth ng structure natin, 0.65, then ma-minus mo dito. Kasi hollow dito, di ba? Dito dadaan yung water. So, minus 0.5 times 0.5. Dito. Tingnan nyo lang dito sa Excel. Then, we are going to get the answer 0.27 square meter. Okay? Then, for our lean concrete. For our lean concrete, same width with our foundation fill. It is 1 meter, 0.1 plus 0.8 plus 0.1 is 1 meter, times the thickness, which is the 50 mm or 0.05 meter. So, calculate nyo lang yun. We are going to get 0.05 square meter. So, ito na lahat yung items of work to be done in constructing our U-type canal. Okay, this structure excavation, foundation fill, structure class B, lean concrete, and the weight of our RSB. So all this is just for 1 meter. Okay, so now how about we have 100 meter? So in this Excel file, it is already prepared here, the table. Okay, so station. how long is the structure. So from example, from 0, station 0 to 1,000. Okay, so nakita nyo, it is programmed here. So, sundan nyo lang dito yung how we calculate. Ito yung formula how we calculate. So, for this item 131A, the structure excavation is 1.44, which is this area, multiplied by our A. Here is our A, the length. Okay, so the answer should be 1,440. And then, just do it the same here. So, ito yung makukuha nyo for the items required, the remaining items. This 404 is for our RSB. So, that's it. So, lagay nyo lang dito how long. 100 example. Okay. Mati-change na dito yung quantity. Okay. That's all. And if you guys want this file, just comment and I'll give you this free. Okay? I hope mas naintindihan natin, or I hope I have explained it much better. Yan lang po. I hope you understand with the explanation I've given. Thank you so much and happy Sunday. So, save ko na to. Bye-bye.